Thanks for watching the screencast. The objective of the screencast is learners will be able to solve a system of equations in 3 variables. So a system of equations in 3 variables is simply a system like the example here that has 3 equations in it. You know, like 1, 2, 3. And each of those equations could have up to 3 variables, x, y, and z, or a, b, and c, or whatever. And we can solve systems of equations in 3 variables as well. What we'll do is we'll use elimination to write 2 new equations that involve the same 2 variables. Or in other words, I'm going to eliminate the same variable 2 different ways. And what that's going to create is it's going to create a little 2x2 system, a system that we've already solved in this course. So what we'll do is we'll solve that system. We'll know 2 of the values, and then we'll use back substitution to find the 3rd value in one of the 3 equations. So it's a process that takes practice. It's in my experience, it's one that requires you to be very organized, and I'm going to make some suggestions in the examples we'll work on how to keep that organized nicely. Another thing I want to say before we look at the example is that with a 2x2 system, a 2-variable system, your answer is an ordered pair like x comma y. And in a system like this, we're going to get an answer that's an ordered triple, x comma y comma z. So let's see if we can solve that system from the last slide. The system of 5x plus 3y plus 2z equals 2, 2x plus y minus z equals 5, and x plus 4y plus 2z equals 16. I strongly suggest for when you're looking back at your work to maybe off to the side number each original equation. This helps if you're looking back at your work later today or next week or whatever. You can look back and you can tell a little bit more easily what you did to find your 2 equations. Panthers, I need to find 2 different ways to eliminate the same variable. And so what I'm looking for, I'm thinking about that elimination process still. I see that I've got a negative z here, and each equation has a positive 2z. So I'm going to try to eliminate the z 2 different ways. So to get my first equation, I'm going to say I need to take equation 1, this thing, and I need to add to it 2 times equation 2. So this is the kind of notation that I'm using when I'm writing out what I'm going to do to create an equation, in this case that has no z's. If I take this equation that has 2z in it, and I add to it 2 times this equation that has negative z in it, I'm going to get no z's. So what I'm going to do now is I'm going to run through that process for my x terms, my y terms, my z's, and the number terms, and I'm going to create a new equation that has no z's in it. So I need to take the first equation, 5x, and add to it 2 of these. If I take this and add 2 of these, I'm going to get 9x. This plus 2 of these. If I do the same thing for the y's, if I take this and I add 2 of these, I get 5y. And now I should get no z's here. This is my plan. This plus 2 of these is 0. And then this plus 2 of these, I believe, would be 12. And what I've done is I've eliminated z one way to get the new equation 9x plus 5y is 12. Now I also want to find a different way to eliminate z. So this time I'm going to take equation 3 with 2z in it, and I'm going to add 2 of these. So my second way, I'm going to take equation 3, and then I'm going to add 2 of equation 2. And I'm going to get a different way to eliminate z. So my plan is that equation 3 plus 2 of equation 2. This plus 2 of these makes 5x. This plus 2 of these makes 6y. This plus 2 of these makes, 26. Now what we have here is a system that we did a whole learning target about already earlier in this course. We can solve this system. I'm thinking usually by elimination is the way I would prefer. I'm looking at my y's, and I think I'd like to multiply this by maybe 6 and this by -5, because that will create 30y and -30y. So I've got 54x plus 30y equals, that's 72. And in my second equation, I've got -25x plus 30y. Oh, no, I'm sorry, minus 30y. And 26 times -5 would be -130. And now if I add these equations together, the y's cancel. 54 minus 25 is 29. So 29x equals, and if I add 72 to a -130, I believe that comes out -58. And now that I've got this equation, I can tell you that x is -58 divided by 29, which is -2. And from here, I'm just going to work my way backwards and find y and z. So now I'll take maybe this equation here, and I'll say, well, if 9 times x plus 5 times y is 12, but wait, I know that x is -2, then I've got -18 plus 5y equals 12. If I add 18 to both sides of that equation, I'm going to get 5y equals 30. And if 5y is 30, y is 6. Okay. And now that I know x and y, I can go back into one of these original equations and find z. I think I'm going to pick that second one, but you could use any of the three. So 2 times x plus y minus z equals 5. But I know that x is -2. I know that y is 6. So let's use those values. This is -4 plus 6 minus z equals 5. -4 plus 6 is 2. 2 minus z is 5 means -z is 3. And if -z is 3, z must be -3. And I think we've done it. I think my answer is going to be x, y, z is an ordered triple. -2 for x, 6 for y, -3 for z. In the interest of your time in this video, I'll leave it to you to confirm that that ordered pair indeed does solve all three of these equations. I checked, it does. You should too. Okay, you know what time it is. It's time for you to try this. Before you pause and try this, I'll tell you that what I see is that I think there's a lot of ways you could go about eliminating a variable and get two equations out of this. I'm going to tell you in advance that what I see is that I think it might be easiest to try to eliminate y when you write your two equations that have two variables. So that's what I'm going to be modeling in a couple of minutes. Maybe you want to try and see if you can do it the same way, even though I think you could find a way to eliminate x and get two new equations, or even z. Hit pause, try this, Panthers, and then hit play and we'll check it out. Okay, I'm going to try to eliminate my y's. Because I see that I've got a -y, and I feel like that would be the easiest thing to use to try to eliminate my 2y and my 3y. So I need to find two different ways to eliminate y. One thing I see that I could do is that I could take equation 2 and then add to that 2 times equation 1. This plus 2 of these would make no y's. So let's do that for everything else as well. Equation 2 plus 2 of these. This plus 2 of these would make negative 5x, right? Because that's 3x, and 2 of these would be negative 8x. This plus 2 of these is 0. That's what I wanted. This plus 2 of these would make plus 5z. And then this plus 2 of this would make negative 15. Another way I could eliminate my y's is to take equation 3 and then take, I guess I would need 3 of these then, wouldn't I? So 3 times equation 1. So let's create a different equation that way. Let me take this plus 3 of these. 3 of these would be negative 12x, so that plus negative 12x is negative 11x. Just to check it out, this plus 3 of these would make 0, good. This plus 3 of these would make plus 4z. And then this plus 3 of these would be negative 27, would just give me 2. And now I can solve this system for x and z. I think I'm going to do this one by trying to get rid of my z's. So I'm going to multiply the top equation, and there are other options here, of course. I'm going to multiply this equation by 4, and I'm going to multiply this one by negative 5. That will give me 20z and negative 20z. So I've got negative 20x in the first equation, plus 20z equals negative 60. In the second equation, if I multiply everything by negative 5, I've got positive 55x minus 20z equals negative 10. If I add those together, try that again. If I add those together, these will cancel. This is 35x equals negative 70. Okay. That means if I divide both sides of that equation by 35, x is negative 2, isn't it? 1 down, 2 to go. I need to now use this value to get z. I think I'll use the second equation, but I could use the first if I wanted to. Negative 11x plus 4z is 2, but wait a minute. I know what x is. X is negative 2. So negative 11 times negative 2 is 22. 22 plus 4z is 2. If I subtract both sides of that equation by 22, I get 4z is negative 20. And if 4z is negative 20, z is negative 5. And now I can find y. I can use any of these equations. I think I'll use the, let's use the second one. 3 times x plus 2y minus z equals 3. But I know that x is negative 2. And I know that z is negative 5. So we've got negative 6 plus 2y, this is plus 5, is 3. These two here combine to make negative 1. Negative 1 plus 2y is 3. If negative 1 plus 2y is 3, 2y is 4. Hey, y is 2. And there's my ordered triple. I've got negative 2 for x, 2 for y, and negative 5 for z. Thanks for watching.